Our next topic in characterizing distributions is central tendency. So most people know these terms, this notion of central tendency is averages. And what it refers to is it refers to scores near the center of the distribution. It's the score towards which the distribution tends. And we're going to talk about a few measures of central tendency: mode, median, and mean. Again, the goal here is to characterize a distribution or a set of scores, and what we're going to do is we're going to describe where the scores tend to be, or this is one way to characterize a distribution, and that is where the scores tend to be, their central tendency. The mode is the most frequent score, and it's very easy to find. It's very simple. It's very straightforward, and that is you find the most frequent score. So in a distribution, you just look in the frequency column, and the one with the highest value is the mode. For this particular distribution, for example, the mode is in the interval 24 to 26. This is the highest frequency of all of the frequencies here, so this is the mode. It's in the interval 24 to 26, or we might characterize it as the midpoint 25. Finding a mode of a distribution from a graph, we just look for the highest point or the highest bar. This is the distribution we constructed from cigarette per day smoked by the people in Tim Baker's study, and what we can see is that the mode is in the interval 16 to 20, or maybe we would say that the midpoint of that interval is 18. That's how we would characterize the mode. The median is a second measure of central tendency that we need to talk about, and that is the score which divides the distribution in half. It's the score at which 50% of the scores are below it and 50% of the scores are above it. It is the 50th percentile. In order to compute that, there's pretty complicated ways to compute the median, but they're all wind up only being estimates anyway. So the best way to guesstimate or estimate the median is to order the scores from highest to lowest, and then you count from the outside in. And you find the middle score, that is the median. In Excel, we're going to be easily calculating this because there's a function called median. The arithmetic mean we symbolize with the letter M or X bar. Sometimes you might see X bar. That also means mean. It's the numerical average. It's the arithmetic average. It's the sum of the scores divided by the number of scores. This is the formula for the arithmetic mean. It's the symbol M. Is what we think of as sample mean, or it's the sum of all the scores, all the X's or all the values that we have, divided by the number of scores. This just means that we're going to sum from, as I goes from 1 to n. If there are I scores, or I is we refer to this as the ith score. We start with the first score, we go to the second, we go to the third, we go to the fourth, and we add up all of these. This is the summation operator, sigma. And basically what it just means is add up all the scores, or sum all the values specified. So what we're going to do is, if we see this sigma x sub I as I goes from 1 to n, what we're going to do is add x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 all the way up to x sub n. How many scores are there? Well, that depends on the sample size. Sometimes there might be 10, there might be 20, there might be 608, there might be 4. So that's why we use this variable n to specify how many observations there are in a sample. Geometric and harmonic means, these are two other types of means that we can calculate. These are characterized distributions in their central tendency. The harmonic mean we're going to use again in the future. I'm not going to spend a whole lot of time on this. This is just n divided by the sum of the reciprocal of all the scores. And the geometric mean, that's a harmonic mean, we designate m sub h. The geometric mean we designate m sub g. Is just the nth root of the product of the x's. So pi is what we call the product operator. Sigma is the summation operator. Pi is the product operator. What we do is just pi x sub I would just mean the product of all the x sub I, x sub 1 times x sub 2 times x sub 3 times x sub 4 all the way up to times x sub n. Again, we're not going to be using the geometric mean a whole lot, but we will use the harmonic mean, believe it or not. So why all the measures of central tendency? I mean, why don't we talk about the right one? Why don't we talk about the correct one? Well, there are different ways to characterize where the scores tend to be, and they all have their strengths. They all have their advantages and disadvantages. Some are more useful than others, but it depends largely on the data. Let me give you an example. If we were to measure household income, we would see that the distribution of household incomes is a highly skewed distribution. Me and probably you are down over here somewhere. I know what I know where this hump is, and I know that I'm on that side of the hump, and I know that your families are very close to my family in terms of household income. So this is where we are. Well, Newt Gingrich and the Saudi royal family and Bill Gates are around here. Bill Gates, makes billions of dollars a year. The Saudi royal family does as well, as Newt Gingrich makes tens of millions of dollars a year. We're down here, they're way up here. If we were to take an average, the mean would come in over here. The mean comes in over here because it's pulled in this direction to the right, I'm sorry. It's pulled to the right by all of these very extremely high scores. They're infrequent. There's only a few of them, but they're extremely high. $63 billion is Bill Gates' estimated worth. That's 63,000 million. That's what 63 billion is. He could give everybody in Whitewater $1 million and have something like 50 billion left over. That's the amount of money that we're talking about here. This is very, very, very large amount of money, and it pulls the average, the arithmetic mean, toward it. The median score is the score that divides the distribution in half. So half of the scores are below it, half of the scores are above it. So half of the household incomes are below it, half are... Now this characterizes where the scores tend to be much better than that. So when we talk about central tendency, the mode or the median will describe the distribution better than the mean, because the mean is equally influenced by all the scores, including extreme but infrequent ones. And hence, if you look up on the internet, if you look up on Wikipedia, what you'll see reported when it comes to household income is you will see data on median household income, not mean household income, but median household income, because the distribution is so skewed that what we have is the mean pulled to this extreme score. So if we really quickly go through, there's a question on your homework that is going to be filling in this table, the pros and cons of the mean, median, and mode. You can look through your book. Your book does a really nice job at summarizing some of the pros or advantages of the mean, median, mode, and some of the disadvantages of the mean, median, mode. So I'd like you to fill that in when you get the chance. However, there are limitations of measures of central tendency in general. Some distributions have identical measures of central tendency but look very different. So if I were to compare the blue and the red distribution here, I would say that we would find that the mean, median, and mode of both of these distributions are identical, yet they look very different. So we need to talk about another measure of, or another way of characterizing these distributions that takes that into account. The shape of these is very different. The spread of these is very different. And that's the topic of the next video. So go ahead and look at that. We're going to be talking about variability in that one.